This chart is on Newton's second law and a little bit on free body diagrams, which I will refer to as FBDs. First of all, the units of force are the Newton, which is a big N. What Newton's second law says is that acceleration is directly proportional to net force. So the vector statement of that is A vector is equal to F net vector over M. And F net vector simply means all of the forces acting on the object of interest, which is why it's important to be able to identify the forces so one can get the net force from that. So the greater the net force, the greater the acceleration, the greater the mass, other things being equal, the smaller the acceleration. So to state it this mathematically, acceleration is directly proportional to the net force and it's inversely proportional to the mass. Generally, what we will do is not deal directly with vector equations, but we'll take the x component of the acceleration, and the equivalent statement is that the x component of the acceleration is the net force in the x direction divided by the mass, and similarly the y component of the acceleration is the sum of the forces in the y direction divided by the mass. So I think it might be good to give a simple example at this point to show how this works out. Let's say we had a 500-gram fan cart. Fan cart is a cart with wheels, of course, and a bed onto which is mounted a fan blade. And if you turn the fan blade on, the fan will push air, let's say, in the backward direction, and there is thereby a force exerted on the cart in a forward direction. So let's say we have a 500-gram fan cart, and it's set on a frictionless level air track, and the fan gives a backward thrust of 1 Newton, let's say. And let's also ignore air resistance, aka drag. So let's draw a free body diagram for the cart before the fan is on. That's over here. So the free body diagram is there's two forces acting on the cart. There's the force on the cart by the earth downwards, and then there's a normal force upwards. I'm using a big N here, and I'm going to quickly switch to a small n to be consistent with what the book says. This would be the normal force on the cart by the air track. Note on this free body diagram that the net force in the y direction is 0. The upward force and the downward force cancel each other. We can tell that they are canceling each other because there is no acceleration in the y direction, consistent with what Newton's law says in the y direction. And since there are no forces in the x direction, there is no acceleration in the x direction. So in other words, a sub x equals a sub y is equal to 0 meters per second per second. Now let's turn the fan on. And in that case, we have an additional force. We still have the two vertical forces we had before, but now if the fan is pushing air to the left, it's pushing the cart to the right. And this additional force now is the force on the cart by the fan. So we still have no acceleration in the y direction, so the two vertical forces cancel out. However, there is only one force in the x direction on the cart, and that is this vertical force. We're ignoring friction, we're ignoring air drag. And so the acceleration in the x direction is given by the net force in the x direction, which is 1 Newton, divided by 500 grams, which is a half a kg, and 1 divided by 1/2 is 2, and therefore the consequent acceleration of the cart is 2 meters per second squared. If in part C we add an extra 500 grams to the cart, then the acceleration of the cart will be less. We still have a net force of 1 Newton acting in the x direction. the free body diagram over here shows that we now have a larger um, weight of the fan cart. In fact, double what it was before. The normal force of the air track is now double, and we have the same um, 1 Newton of thrust. Then the acceleration from Newton number 2 is going to be 1 Newton divided by 1 kilogram, which is 1 meter per second per second. So keeping the force the same and doubling the mass has halved the acceleration, as you can see by comparing these two numbers. So a couple of questions for you. Question 1, what is the acceleration of if the fan cart mass is 200 grams and the fan motor thrust is increased to 3 newtons? Question number 2, for a fan cart mass of 200 grams, what fan thrust is required to make the fan cart move 1 meter in 5 seconds, assuming it starts from rest? For this second one, you are going to need to use Newton's second law and in combination with the kinematic equations.